Valence bond theory. A covalent bond between two atoms is formed when a pair of electrons is shared by two overlapping atomic orbitals. So we focus on the orbital of the valence electron. That's why the name is valence bond theory, because we focus on the valence electron. Example, H2 hydrogen molecule, one hydrogen atom, electronic configuration 1s1. This is the orbital diagram, and 1s orbital shape sphere. So one hydrogen sphere orbital shape and another hydrogen with 1s sphere orbital shape. These two electrons pair together and a covalent bond is formed by sharing two overlapping atomic orbitals. This is the region of atomic orbital overlap. This orbital overlap with another orbital, and this is the region of the overlapping atomic orbital. Each hydrogen atom has one unpaired electron, one hydrogen, one unpaired electron, another hydrogen, one unpaired electron in its valence shell, because we focus on valence bond theory, so it's valence shell. Both hydrogen atoms are far apart initially. Next, atoms begin to interact as they move closer to each other. As the two atoms approach each other, their 1s orbitals overlap, here the orbital overlapping region, and their electron pairs spread out over both orbitals. These are the electron from H on the left and electron from H on the right, and electron pairs spread out over both orbitals as the two atoms approach each other. So this is the region of the orbital overlap. Example, HF hydrogen fluoride, one electron from hydrogen and one unpaired electron. Note that orbital overlap only involve unpaired electron from each atom, not pair electron, unpaired electron from each atom. So one unpaired electron from hydrogen, and from fluorine you cannot take the electron in 2s, because in 2s there are paired electron. In 2p, for the first orbital, paired electron, so don't take from this orbital, and the next 2p orbital still paired electron, don't use these two electron, use the unpaired electron. Only unpaired electron from each atom can be used for orbital overlap. So these two unpaired electrons form orbital overlap in the middle to form covalent bond according to valence bond theory. For fluorine, one unpaired electron from one fluorine and another unpaired electron from another fluorine. Both electrons will be paired in covalent bond, and this region is called orbital overlap. Mode of overlap. There are two modes of overlap. The first one is end-to-end. End-to-end overlap will result in sigma bond. Secondly, side-to-side overlap. Side-to-side overlap will result in pi bond. End-to-end overlap, 1s orbital overlap with electron of 2p orbital, and it forms sigma bond, means single bond. The side-to-side overlap usually will cause pi bond. So the overlap, if you notice, side-to-side and end-to-end overlap is different. End-to-end overlap form one sigma bond. single bond. But side-to-side overlap has two overlapping area. Here, this one is 2p and another 2p. Okay, the overlapping is on top and another overlap is below part, is on the below part. End-to-end overlap, just one region of overlap. For side-to-side, two region of overlap, but still only form one pi bond. Even though there are two regions of side-to-side overlap, only one pi bond is formed. Here, one region overlap, one sigma bond is formed. Side-to-side overlap, two region overlapping, only one pi bond. Sigma bond resulting from end-to-end overlap. So here, end-to-end overlap, for example, 1s overlap with 1s, 1s overlap with 2p, 3p overlap with 3p. This is sp orbitals. There are two sp orbital here. The sp orbital is hybridized orbital. One sp orbital, two sp orbital. So these two sp orbital overlap with one 3p orbital, forming sigma bond, means single bond. And one s orbital overlap with two sp hybridized orbital, form sigma bond. All single bonds are s bond, sigma bond. All single bonds are sigma bonds. So the sigma bond allows free rotation of the atom in the molecule. The sigma bond has highest electron density along the bond axis. So this is along the bond axis. Along the bond axis, highest electron density. Pi bond resulting from side-to-side overlap, sideways, not end-to-end. End-to-end will form sigma bond. Pi bond resulting side-to-side overlap has two regions of electron density. If you notice, this one 3D drawing. On top, there's overlap on top and another overlapping area on the below part. Two regions of electron density, 1, 2. One above, one below the sigma bond axis. So usually here is the position of the sigma bond axis because sigma bond end to end. So it's on top and below the sigma bond axis. One pi bond hold two electrons. One pi bond hold two electrons that move through both regions of the bond. Pi bond restricts the rotation. So the rotation of the orbital cannot be done due to the pi bond. For example, the overlapping between 2pz orbital and another 2pz orbital. This is the side-to-side overlap, two regions of overlapping forming one pi bond. This one pi bond, even though two regions of overlapping only form one pi bond, the one pi bond holds two electrons that move through both regions of the bond. And the side-to-side overlap restricts the rotation. Double bond consists of one sigma bond and one pi bond. For example, this oxygen molecule has double bond. One of the bond is pi bond and another bond is sigma bond. Triple bond, if you have three bonds, for example in N2 molecule, triple bond consists of one sigma bond and two pi bond. If only single bond, only sigma bond. Double bond, one sigma, one pi. Triple bond, one sigma, two pi bonds. Example, for oxygen molecule has one sigma bond and one pi bond because oxygen molecule has two unpaired electrons. So this one unpaired electron will form sigma bond with another unpaired electron. One more unpaired electron will form pi bond with another unpaired electron. These two unpaired electrons will form sigma bond, end-to-end overlap, so one overlap sigma bond, and side-to-side overlap. These two unpaired electrons form side-to-side overlap, one on top, one below. This is side-to-side overlap. Note that the electron spin must be opposite, one pointing upwards, another one pointing downwards. So this is side-to-side overlap. Even though the overlapping involves two overlapping, one on top, one below. So one on top the sigma bond, one below the sigma bond. Even though the overlapping areas are two overlapping areas, still this pi bond is only one bond. One sigma bond, one pi bond, only one bond as well. Even though the overlapping regions are two regions, on top and below. Next, nitrogen. Nitrogen molecule, one nitrogen atom has three unpaired electrons. Another nitrogen atom, three unpaired electrons. One unpaired electron will form sigma bond with another unpaired electron. This one, second unpaired electron of nitrogen 1 will form pi bond with a second unpaired electron of nitrogen 2. The third unpaired electron of nitrogen 1 will be paired with the third unpaired electron of nitrogen 2, and they will form another one pi bond. So in this one, let's say this is electron in px, electron py, electron pz. The unpaired electron in px will form sigma bond with unpaired electron of px. Their orientation must be the same to form the bond. This one, py, 2py, will form pi bond with another 2py. So they must be paired together. The orientation must be the same. And 2pz will form another pi bond with 2pz of this nitrogen atom. So this is, you have to write 2px will form sigma bond with 2px. So this is a paired electron. And 2py, let's say in green, this is 2py orientation. It must be the same orientation of this 2py. And the electron spin must be opposite. And you have to draw the line of 2py bond. So make sure you note 2py and this one 2py. And the final one, 2pz, form pi bond with 2pz. This one, different orientation from py, pz. This is 2pz and the orientation must be the same, like this, 2pz. And draw the line on top, another one below, and make sure you write down 2pz, 2pz. The electron spin must be different, one pointing upward, the other pair must pointing downwards. That's how you draw orbital overlap. Usually, orbital overlap involve the molecule with same atoms, O2, N2,